Okay, so for today, guys, I want this to kind of be our last day on like just working on problems for Newton. I'd like to be able to do the assignment Monday because we're getting through the problems fairly quickly. Like there aren't a lot of them left, especially ones that I think are like good or challenging. Okay, so I've got a few that I want to be able to go over in class today. Okay, so I want you to try them, and then periodically I'm just going to put them up on the board and we'll go through the solutions and whatever little like idiosyncrasy or like challenge each one of those problems had, because each one of these has some little thing in it, okay, that is kind of important for us to experience and know for the future. All right, so the problems I would like you working on are from that workbook. Okay, the first three are inclined plane problems. Okay, and their one trick is kind of like one we had yesterday, that where they give you the weight and not the mass. Okay, so ones to watch out for there. Those are on page 3 of the digital workbook, 23, 24, and 25. Okay, then I'd like you to leave those ones for last. Okay, I know they're first, but that's just the order the workbook went in when I was writing them down. Okay, what I would like for you to try first are 6, 9, 11, and 12. Okay, from the inclined planes worksheet, and number 5 from the vector quantity worksheet. Okay, each one of these has some little thing in them that just makes them a little bit different. Okay, for us to kind of go over and make sure we understand. Okay, and then we'll go back if there's time to 23, 24, and 25. Okay, and then I think on Monday we will look at. Actually, no, we won't do the assignment yet because I need to go over friction before we can do the assignment. So Monday will be new stuff on friction. Okay, so let's work on that for today. Okay, and as I said, I'll go through them kind of one at a time here every 5, 10 minutes or so. Okay. Okay, so the thing with number 6 is we've never been asked to calculate the mass using the information from the inclined plane. This is like the only problem we've had where that's been the case. We've had to calculate the mass when we were given a weight, okay? But we've never had to start the problem with basically no way to get it and work backwards to it, okay? And this is one that works that way. So we've got the inclined plane, okay? And Homer is up here, and we don't know what his mass is. But we do know that this internal triangle is still the same. We know that this side's the force of gravity, which without the mass we can't calculate. We know that this side is the normal force, which without force of gravity we can't calculate. Okay? And we know that this side is F parallel, which we might be able to get based on the information they give us. We know this angle is 22 degrees, so this angle is 22 degrees. Okay? It says friction is opposing his motion with 20 newtons worth of force. And it says that his acceleration, or he was accelerated down the hill by a net force of 460 newtons. All right, so we know what F net is. Okay, I don't have the acceleration, so I can't just go F net over acceleration to get mass. Agreed? All right. Since I know what the sum of all the forces is, can I get this force with that? I can, because those are really the only two forces that we're concerned with. Okay? If I can get F parallel, what can that help me get? Right. I've got to work completely backwards to everything we've ever done with an inclined plane question for this one. Okay? I've got to get F parallel so I can get FG, so I can get the mass, which is like we always start with the mass, get FG, get F parallel, and then go to the acceleration from there. Okay, this one's just completely backwards. All right, so F parallel must be 480 newtons. Okay, because F net is 460, okay, so that means that 460 equals F parallel plus the force of friction, with the force of friction being negative. Okay, so it would have to be 480 plus negative 20, right, to get 460. Everyone okay with my reasoning there? Okay. So now that I know F parallel is 480, now I can work backwards to get FG. I know that the sine of 22 is going to equal 480 divided by the force of gravity. Okay, opposite over hypotenuse. So I'm just gonna flip these so that I can get FG. 480 divided by the sine of 22 will give me Homer's weight. Okay, not his mass, his weight, the force of gravity acting on his mass. Okay, come on. Okay, so Homer's weight is 1,281 newtons. Homer's a big guy. Okay, there have been several times where he has stepped on the scale in the course of The Simpsons, and he has been north of 300 pounds. Okay, so he's a big guy. We're going to divide that now by 9.81 to get his mass. And his mass is 131 kilograms. That's 287 pounds. Okay, not unreasonable for Homer if, he's gone on some sort of diet where he didn't eat like pork rinds for a while or something. Okay? All right. Everybody okay with how that one worked? But definitely different, right? And that's what we have to be ready for, is there a way that Mr. Codere can ask me an inclined plane question that makes me have to do things differently? It's still all the same stuff. I just changed the order you had to do it in. Okay? And that can sometimes be challenging because it's just something a little different.
Why did you multiply it by 2.2?
Oh, I just was getting it in pounds for you.
Oh.
Sometimes we just don't, I look at things in kilograms and go, I have no idea. Yeah, pounds makes more sense. Like when I look at something in centimeters. Somebody says, well, I'm 195 centimeters. I'm like, what is that, 6'4", something like that? Okay. All right, keep going there, guys. We'll go over, next one is 9, right? So we'll go over 9. I got a little video to go along with number 9. Okay, I'll look at that in a minute. Okay, so this one actually isn't all that different than the ones we've done in the past. I just wanted to be able to show you the avalanche video. Okay. So we got our avalanche going down the slope, okay, and the slope is 50 degrees, so way bigger than I drew it. Okay, that's the snow. And the snow has a mass of 2,500 kilograms. Okay, and it's accelerating at 6.5 meters per second squared. What can I calculate right now?
Force of gravity.
That I can, and what else?
F net.
F net. Okay, so I got to do my F net. Okay, so F net will be 2,500 times 6.5. Okay, and so that's 16,250 newtons down the slope. All right, and yes, we do have to calculate our force of gravity because obviously we want that whole internal triangle, okay, to work for us. Okay, so Fg is going to be our 2,500 times 9.81. All right, so 24,525. Okay, and then to get F parallel, I'll go sine of 50 times Fg. All right, so that's 18,787 newtons down the slope. So we're looking for the force of friction between the snow and the mountain. Okay, so that's the thing we're looking for there. All right, so that'll be F net minus F parallel. They're both down the hill. Okay, so that should give us a negative number acting up the hill when we do it. So 16,250 minus this number, okay, gives us 2.5 times 10 to the, well, actually I have 2.54 there. Because I probably rounded off my trig before, up the slope, okay, because I got a negative number and I treated it down as positive. Okay, everybody all right with that one? We've done lots like that one. Okay, how many people are done number 11? Hands up, done 11? Okay, I'll give you a few more minutes on 11. It's got a pulley in it, okay, so it's an inclined plane, but it's also a system. This one was on final exam once.
Could you you bring it back when it's 12?
Oh, bring, okay. let's have a look at 11. Oh, I was recording all that silence. Wonderful. Okay, so we have, okay, this situation here where we've got mass 1 being 2 kilograms, okay, and mass 2 is 2.5 kilograms. Okay, so people really get thrown by this question just because it looks intimidating. Is this any different than pushing something up a hill? Other than when you get the net force, you have to keep in mind it's how much mass? 4.5 kilograms. That's really all that changes. Okay? The force of gravity that's pulling on the 2.5 kilogram mass is going to be our force upwards on the 2 kilogram mass. Okay? What's pulling down on the 2 kilogram mass? Okay, pulling, yes, straight down is gravity. What's pulling down the ramp? What's always pulling down the ramp?
Or
Parallel, F parallel. Okay? When we're coming right down to it, this question comes down to 4.5 kilograms being accelerated by the net force between gravity and F parallel because it tells us that the plane is frictionless. Those are the only two forces that contribute to the movement of the 4.5 kilograms of mass in this system. Right? So I still have to calculate F parallel. Right? It's a 30-degree angle. They told us that. So FG is going to be 19.62. Right? And then F parallel is going to be here. This angle's 30 degrees. So that means that F parallel is the sine of 30 times 19.62, which means it's 9.81 newtons. Okay? So F parallel is 9.81 newtons. This force of gravity here is 24.525 newtons. Okay, can I simplify my diagram now? Just like I would with any other pulley system. I got 4.5 kilograms worth of mass being pulled this way by 24.525 newtons and resisted this way by 9.81 newtons. All right, my net force is going to be the vector sum of those things, so that minus 9.81. There's my net force, 14.715. Okay, can I get the acceleration now of mass 1? By calculating the acceleration of the whole thing, exactly, and that's the trick, right? F net over m, so 14.715 divided by 4.5 kilograms, because that's what's happening here, okay? And that is going to give us our 3.26 meters per second squared up the ramp, because they asked about mass 1. So we can give the direction up the ramp. Okay? So, when you first look at that question, does it look like it's that much work? It looks like it's more work. Okay? It looks like, oh my God, what am I going to do here? Okay? But in the end, it's an upward force and F parallel. And combine the masses. Okay? Yeah, we had to combine two things. But Coderre likes to do stuff like that on tests because it means less questions. Right? I just tested 2 kinds of questions with 1 question. Okay? Rather than having to make the test really long. Okay? 2, fairly simple concepts on their own combined into 1. Okay? You see how I tried to sell that to you as like I'm doing you a favor here? I know you're not buying it right now, and that's okay, but yeah. All right. So the key words in number 12 are constant velocity. I'll give you a couple more minutes on number 12 before we go through that one. What do we got here? Yeah, we got like 10 minutes. So we also haven't had one where we had to find the angle. Okay, so this is also something that's a little bit different. So we have our inclined plane. We don't know what theta is, okay, but everything still sets up the same. Okay, it's a 3,000 kilogram truck. Okay, we can calculate the force of gravity. Okay, so 3,000 times 9.81, and it gives us 29,430. newtons, okay? We're gonna need F parallel, but we don't know what it is yet, but there's gotta be a way to get it, because that's the only way I can think of to get the angle, is to have two sides of that triangle on the inside, all right? So we know that friction is opposing with 1600 newtons, and we know that the truck is traveling at a constant velocity. What does that help me get? F net. What's F net? Right, so what's that parallel?
Wow, it's maybe
It's 1600 newtons. If this thing's going at a constant velocity, that means that the force up and the force down have to be balanced and cancel each other out, a vector sum of 0. Right, so now I know this side is 1600 newtons. Can I get the angle? Now I got two sides of the triangle, right? So I just go inverse sine, so theta will be the sine to the -1 of the opposite side, 1600, divided by 29,430. And when I do that, I get that this is not a very steep hill, 3.11 degrees. Okay? Again, not one we've had before. We weren't ever asked to calculate the angle, but we had to work backwards and get it. Okay? So again, it's all the same steps. It's still using the same concepts, knowing constant velocity means net force is 0. All those things, they just keep coming up. All I can do is shift the order around. Okay? How many people have had a chance to do number 5 on the vector quantity sheet? Anybody? Okay. I'm just going to put it up here and we'll have a quick look at it. Okay, so if you guys can give that one a try, maybe we'll look at that first thing on Monday before I go over friction. Okay? It's not that difficult, it's just got vectors in it, you've got to do some x's and y's and stuff.